Welcome back to INST 314, Statistics for Information Science. We're continuing our walk down the path of statistical foundations, and this time moving into the data collection principles. This is a very exciting topic because this is what really helps us figure out how we go ahead and get the observations we need that will be used to infer back to our populations and make sure that hopefully we're representative. So the lecture goals for this particular talk is really to focus in on our sampling techniques for data collection. Future videos will be taking how we use those samples, bringing into inferential analysis, and moving forward from there. So let's go ahead and jump into data collection principles. Recall that we have this thing we call a population. They've got some sort of underlying characteristic, but they're often hard to measure for a wide variety of reasons, and therefore we have to take samples or portions of them from the population to be able to talk about them statistically. One of the big problems with these populations is that they're so large that it's difficult to go ahead and get information from everyone. The difficulty often stems as a resource problem. We never have enough time, money, people to help us out, and therefore we have to go ahead and use a sampling solution. Samples are our strategies of how we're going to go ahead and collect a portion of the population to become our sample. And there's many different ways that we can do this. But what we're really looking to do is be what we call representative, such that when you go ahead and collect your sample, that sample will have enough of the same characteristics that it will reflect the population. So if I said that the average age of the student in this classroom is, let's say 20, then hopefully if I'm trying to infer back to the iSchool as my population of students, that the average age of the population is going to be approximately 20. If for some reason the iSchool age was actually including the graduate students as well, but your class is only undergrads, then I'm not necessarily going to be representative because my sample, you as the class, is not necessarily going to be reflective of the iSchool more broadly. So how can we go ahead and ensure that everybody is representative? The EPSEM stands for Equal Probability Selection Method sampling. This is the gold star, the top-notch method. It doesn't really get better than this to make sure that you're representative. Essentially what we're saying is that everybody or everything that is part of the population has an equal chance of being drawn into the sample, and therefore it's likely to be representative because it's also that these equally potentially selected groups has been selected randomly. So equal chances chosen randomly into the sample. That's the EPSEM. So we often call this as simple random. That's the shorthand version for the EPSEM. But there's a few other sampling techniques that we're going to talk about here. Stratified random, cluster, multistage, systematic random, and convenience. Let's go ahead and look at each of them in turn. So we already mentioned before about the simple random sampling, and here's just a graphical representation of it, where we have the universe of observations as the blue dots. That's our population. And then those that were sampled that had an equal chance and chosen randomly, those are the ones that are dotted red with circles around them. Stratified random is where we go ahead and we break up the population into what we call stratum. So we've grouped them usually on some sort of characteristic. You can think of it if this was a geographical thing, maybe we did it by city block. And then from there, we've randomly chosen a group of observations from within each stratum. So you group them by stratum, and then you randomly choose an equal number from within them. Note on here that there were 3 within each of the stratums, so we've got them spread across the stratum. They're not uneven. Cluster sampling is a variation. So we're still breaking up the population into groups, in this case clusters, but then we go ahead and sample everyone in a particular cluster. This is different from the stratified random because we're getting everyone in the cluster instead of just choosing a random few. Multistage cluster sampling is a bit more like the stratified random, where we're breaking them up into clusters, and then we're randomly sampling within that cluster. But where this differs from the stratified random is that in the stratified random, we're taking random samples from every stratum, where in the multistage cluster, we're breaking them up into clusters, randomly choosing which clusters to sample from, and then randomly choosing a few within that particular cluster, hence the multi in the multistage. Systematic random sampling is a little bit different from the rest that we're looking at here. At this point, we go ahead and we start with a roster of all the potential people or objects or whatever it is that's in our population. We put them into a long list, a roster. We start with some particular number, often randomly chosen, and then we sample every nth position from there. So the graphic up on the slide right here shows that we have a population of 12, and we've started with the second, and then we're sampling it every third. So we would choose 2, 5, 8, and 11 to become our members of our sample. Part of the key to making sure your systematic random sampling can work well is that your roster isn't organized in a particular way that it would lead to potentially having that random not be so random. So you can go ahead and randomize your roster based on some random generation, or you can group them if you want to do it like alphabetically or by some point scoring or something to that nature, so long as you're not causing clusters or other characteristics of the people or objects in your list to form of a particular sort of way. So it's really on a case-by-case basis. The last one we're going to talk about here is convenience sampling. And this is where we have a broader population, but we're only going to capture into that sample those that are easy to collect. Think of this as going across the quad and somebody comes up and says, hey, would you like to go ahead and sign my petition or take my survey or do X, whatever X is. In this case, the only people that are going to be part of that sample are going to be those that, first of all, could have been passing by in the first place. So if you were in class, whether it was in the hall right next door or halfway across campus, you could not be in that particular sample because you were not walking through the quad at that time. Also, you had to be willing to join that particular sample. It was a voluntary action, so you could walk past the quad, the person could ask you, you could say no and keep walking, in which case you would not be part of that convenience sample. The convenience sampling is the least rigorous of all of the different methods because of its pitfalls, but it's still often used because of its ease of data collection. We just need to recognize the problems with it depending on the type of data analysis we're doing. So let's go ahead and look at a few different examples of potential ways we can collect sampling and figure out which one would be used in these situations. So the first one says, some students set up a table at Stamp Union and ask everyone who passes by about their opinion on student housing. This might sound familiar to one we just referenced. The second one says, when looking at Yelp reviews, a food critic groups restaurants by the city and then randomly selects a few from each city. Third, to check for defects, a worker at a factory opens up 5 cases in 1,000 and checks to see if all units are okay within that case. And lastly, the head of a department decides to check student engagement by randomly picking 3 students from each course in that department. Go ahead and pause the video now, back up a little bit if you need to look those over, and think about which sampling strategy is used in each one. Go ahead, I'll wait. Alright, so let's go ahead and break out some of these here. The first one, where we're looking at the students at Stamp and asking people who pass by, that one would be convenience sampling, the one we just mentioned. We're only going to go ahead and collect those that passed by at that time and were willing to share their opinion. The second one, looking at the Yelp reviews by the food critic by cities, is the stratified random. Note that the food critic grouped all of the restaurants by their cities and then randomly selected by each city. If the food critic had grouped them by city and then randomly chosen a few cities and then randomly chosen a few restaurants in those, that would be a multi-stage cluster. But in this case, each city's been chosen and then a few from within each one have been selected. So this is the stratified random. The cluster sampling is the next one, where the worker at the factory opened up 5 cases out of 1,000 and checked to see if all the units in that case were identified. So this is the cluster. 1,000 units went past, 5 were picked, every unit within that 5 cases. That's our definition for the cluster. And then lastly, the department head looking on student engagement. That's just a simple random. The department head has a full roster of all the students in the department, can make sure that it's randomly sorted, and then randomly selects 3 from them. So that's our equal probability, the EPSEM that we're looking at, and the best of all of the options we can choose. Now we have to be concerned about what we call bias and generalizability. 2 key terms to add to your jargon textbook here. Generalizability is a big one where we're talking about you have a sample, Well, how well does that sample represent back to the population? So if your sample is generalizable, the more generalizable it is, then the more representative it is of that population. And you can have challenges to your generalizability because of issues of bias. This is where generalizability is different a bit from representative. Representative just means of your sampling strategy and things that you had, how well can you represent the population? You could have biases that distort the generalizability and hence affect your representativeness. Now, biases, like I just said, are distorting issues. And there's different types. Sampling bias, also called selection bias, is one type, and the one that we're going to focus on in this class. But depending on where you go into your research methods, you will learn about all sorts of different kinds of bias. So on sampling biases, also known as selection bias, there's three that I want to cover on here. The undercoverage bias is an inadequate sampling. So this happens to cause problems with overrepresentation and underrepresentation in our sample. Think about it with people who still actually have landlines versus those that have cell phones. A common method for many national surveys, especially those that are administered by the US government, still rely on the method of dialing landlines. And so if more and more people are disconnecting their landlines, then we could have an undercoverage bias because the sample is only going to contain those who have their landlines and aren't calling people who've moved entirely to cell phones. Voluntary response bias, that's a self-selection issue. This is, think about with the convenience sample, where you're only going to go ahead and get people in your sample who wanted to participate. If you're doing a drug trial and you put out an advert and you said, we're looking for people of this age and these characteristics to go ahead and join our sample or for these drug trials, and we're going to give you this sort of compensation. You're only going to get those who are willing to participate, volunteer themselves. So the bias is going to come in from all those who did not volunteer, and their information could be quite valid and potentially different from those that are in your voluntary sample. The last one is non-response bias. This one is when you have individuals or objects or whatever it is you're measuring that are a part of your sample, but for some reason they are unwilling or unable to respond. So think about this when you often comes a time in surveys, somebody will ask a sensitive question, and all of a sudden you're not so willing to answer that particular question, and you indicate it as such. So you're part of the sample, you may have participated on other questions, and your data is going in, but you've answered non-responses into the data as far as that goes. So this is pretty much where we're going to wrap up the data collection principles, and I'll go ahead and see you guys on the next video when we link this to our inferential processes.